Hi, listeners. Welcome back to The Data Layer, the podcast hosted by Appen, where we power the human data for frontier AI. I'm your host, Karla Heredia. I'm the director of Gen AI at Appen, and this is episode 2. And we're so happy to welcome today's guests, Alex Whedon, CTO of Subquadratic, and Sergio Bruccoleri, VP of Delivery here at Appen. And today we're going to start with where AI is actually heading, agents, long context, and real world deployment. Hey, Alex. Hey, Sergio. Could you introduce yourselves and your company for our listeners?
Sure. Yeah, I'm Alex. I'm co-founder and CTO here at Subquadratic, and we are a foundation model company building the most compute, memory, and sample efficient algorithms upon which we can build models. And we believe that with the most efficient algorithm, you can make the best models and create all sorts of downstream benefits that would be hard for anybody else to do.
And I'm Sergio. I head our delivery operations here at Appen. So anything that has to do with the human data layer that fuels frontier models, from collection and creation of data to annotation, as well as the research that goes behind creating the best pipelines for model data.
Alex, I'm curious. Could you tell us what Subquadratic is building and what's the core of the problem that you're trying to solve?
Sure. The core of the problem is just that scaling laws for AI are not good right now. They haven't been for a long time. So I've been in the space since 2016. First started working with LSTMs. They had linear compute complexity, but weren't parallelizable on GPUs. In 2017, with the transformer architecture, everybody moved to this new architecture, but it had quadratic compute complexity. So if you double the input size, you quadruple the compute requirements. If you 10x the input size, you 100x the compute requirements. The more data you give to the model, the less efficient it gets. And anybody who's been through a software engineering interview knows that a big O of n squared is a failing grade. So we've been effectively building on top of this failing grade algorithm for the last 9 years. And I've long anticipated that would need to be replaced, and that's exactly what we're focused on. So on the compute scaling law side, we've released subquadratic sparse attention that enables us to build LLMs with full linear compute scaling laws. So the compute required per token is fixed as opposed to getting progressively worse as inputs grow. We have non-attention algorithms that we're working on to decrease the memory requirements dramatically, and also improve the sample efficiency. And with these algorithmic differentials, we're able to do more training with the same compute to make smarter models. We're able to train on larger inputs to introduce new capabilities to the models that have yet to exist today, like the long context reasoning capabilities that we're building, or in multimodality, where a single minute of video is about 400,000 tokens. And then we're enabling people to build applications differently through larger, cheaper, faster, and higher intelligence context, amongst other things. So that's the TLDR.
And Sergio, how did this collaboration between Appen and Subquadratic happen?
I think it's an interesting one. I think, Alex, you had worked with Appen in the past at your previous companies, where you were very familiar with our platform and our services. And of course, when Subquadratic reached out, their main focus was the benchmark, as you know, as they're creating pretty much new technology, and all of the claims that Alex just made on sparse attention, it becomes a challenge of how do you validate those claims and how do you do that independently. So we were super happy to jump in and actually validate the real performance of the model, not only in terms of, the most common benchmarks, if we look at coding, for example, but also the claims around long context and performance on long context. And also, I would say, even most importantly, the computing side, right? So Alex just mentioned, how can you do more things with less computing? And they definitely have a model that delivers on that promise. And Appen was just here to validate it independently and just make sure that they actually could make those claims.
I can also share how I worked with Appen in the past and why we decided to partner with Appen. So back in 2020 and 2021, I was at a research lab And we were getting a lot of high volume data from immature, but we wanted to complement that with even higher quality data. And so we worked with Appen to get a bunch of higher quality data from like higher tier experts. And then additionally in 2023, I put in a bid with one of the top labs when I was doing consulting to do some benchmarking, and Appen beat me in that bid. And so that was my clear data point of who was doing the frontier benchmarking for the frontier labs, so I figured we'd have a great experience with Appen.
I didn't know that last one.
Yeah.
I'm proud of that one.
Yeah.
There you go. I'm sorry then.
So this has been a long-standing relationship, but I want to talk about the future. So the industry has shifted. And we're not just asking AI to answer questions anymore. We're asking it to take actions, to run workflows, operate autonomously. So Alex, where do you see agents going in the next 12 years, and what does the infrastructure need to look like to support them?
Yeah. So the next like 12 to 18 months, we're going to see a lot of changes when it comes to agents. One is longer horizon agenda capabilities. That's the key to full autonomy is the ability to plan, execute, and review, and then execute fully autonomously over like longer horizon. And then I also think we're going to see more multimodality. Be able to analyze images, analyze video content, analyze real-time streams from video feeds, etc. And then finally, we'll see some agentic pipelines leaving the cloud. We're already seeing that more and more agentic pipelines are being run on like laptops or desktops, and then we're also going to see in robotics. So, and that's going to dramatically change the need for algorithmic efficiency as well.
What kind of agent use are you hearing from the people that are building Subquadratic today? I know you hit on multimodal, but is there anything outside or more?
Yeah, absolutely. So there are a couple different ways that we're plugging into the agentic space right now. One of them is that today, like agents are fairly inefficient with context. And that may sound strange because everybody's trying to be as efficient as possible with context, trying to reduce the number of tokens they're using. But the reality is that what that ends up doing is creating this long-running surgical management of context. One example of that is that we benchmarked one of the frontier models on Bench Pro back in, I think, April. And we found that the model took an average of 66 steps to complete the problems. And the vast majority, I forget the exact number, but I think around 90% of the steps were read steps. And so only the last 10% or so of the steps were execution and review. And that's because the model struggles to reason over with low cost, low latency, or high intelligence large amounts of context. And so it's surgically managing the context of a very large number of steps, which actually increases the user latency and potentially leads to missing details. The reality is that the model doesn't know what it doesn't know. It doesn't know what it hasn't seen. And so it's missing this holistic overview, which can lead to errors in addition to the latency. So we are enabling people to build agents where each step in the agentic workflow is more ambitious. It covers more ground, leading to faster pipelines, in aggregate cheaper pipelines, because the aggregate token usage is actually lesser if the model can be more ambitious with each step. And then we also have lower token costs. And then finally, the second place where we're plugging into agents that we find really interesting is the long horizon memory layer, long horizon memory and orchestration layer. So, I do feel that across all types of agents, but including coding agents, the big thing that's missing is this long horizon context, the fact that every time I start a session, it feels fresh. And so we're working with people to create memory that spans not just multiple sessions, but multiple weeks, which is really important for workforce productivity.
I think there was one aspect that you had mentioned last time we spoke as well, which was specifically on robotics and how you feel like long context is gonna benefit robotics. It'd be nice for you to sort of share it again, because I thought that when you said it, it was like, oh, I hadn't thought about that.
No, totally. Yeah, if you want to talk about robotics theses, I'd be happy to. We haven't talked too much publicly about that yet, but it's really important and relevant to the work that we're doing on memory compression. But we have algorithms that we're working with that are attentionless and don't use a KV cache at all, and we think that's going to be absolutely necessary for general robotics intelligence. Again, this is a bit separate from the enterprise agent work that we're doing today in commercialization, but for robotics, the reason why you see these demos, like the Figure AI demo, where it's flipping a box on a what is that called, like a conveyor belt. The reason why you're seeing that demo is because it requires only like a 10 to 15 second like memory span. And the reality is that for general robotics intelligence, the tasks are going to look very different. So if you ask a robot to fold the laundry, then it needs to remember the roadmap of the house and figure out how to navigate that, and then remember how to open the door of the laundry machine, and remember which cycles are appropriate for which types of clothing, and remember what the user's preferences are for folding the clothes, and remember where to put each clothing item in which room, and then finally, so that's the first, like, longer horizon memory is going to be required. Additionally, I think in the robotics space, we're at the same place we were in 2019 with language models. In 2019, we trained task-specific language models where we curate, 1,000 samples plus for each task individually, and it was super cumbersome. And then OpenAI became the lead actually with this GPT-3 release, and became the lead in the industry and said LLMs are now zero-shot learners, or few-shot learners. Few-shot learners, not zero-shot learners, which meant that you could provide a few examples in the prompt of how to achieve the task, and the model would be able to learn your task in context. We now call that in-context learning, and so we went from needing to curate all these examples for training to just being able to prompt a model, which that's very much a huge part of the industry today. That's going to be required, I think, in the robotics space as well. Like, we cannot scale to the level that we want if we continue down the path that we are going right now, where we have to collect like thousands of super expensive trajectories for each task individually. We're going to need to be able to effectively video prompt the model for new tasks. And when a single minute of video is about 400,000 tokens, that's for the Lava model as a benchmark, then you need like 4 million tokens for a 10-minute example. And if we're struggling to do that in the cloud, how are we going to do that on a 16 gigabyte VRAM chip that has about the same memory as your phone? So we do, per that measurement, need at least a 100x memory compression from where we are today, which means that transformers are not going to get us there. We do need non-transformer algorithms for that have far greater memory compression. So, but that's like more forward thinking. It is something we're actively working on and evaluating. But we have some benchmarks that maybe we'll run past you guys in the, I don't know exactly what time frame, but very separate from our immediate commercialization around long context reasoning and long horizon agents.
Oh, I like this future view, Alex. But Sergio, I want to go over to the evaluation side. How do you test a model's fitness for agentic deployment?
Yeah, that's a good question. So we always test a model fitness for agentic deployment by really moving beyond the single turn benchmark accuracy. So can it reliably complete real workflows, right? And traditionally that means, evaluating the full trajectory. Can it understand the objective? Does it choose the right tools to complete those objectives? Does it make sensible decision across multiple steps? Does it recover if there is a failure? Does it respect permissions, and does it know when to stop or when to escalate it to a human, right? So, of course, traditionally this has been done through, task success rates, pass at one, to use accuracy, failure mode, latency, and of course cost per successful outcome, right? It's how many steps does it really have to take? How many tokens does it really have to take to complete an action? And different models have different level of verbosity, I would say, in how they go about completing a task, as well as just the amount of steps that they use to complete a task. I think when you additionally, I think as a complexity, when you look at a model like what SubQ is building, it's pretty much you also have to expand their evaluation beyond that and go to, can it retrieve, prioritize, and reason the right information across a very large context window? And that's something that even the industry isn't super aligned on how to test, but it becomes extremely complex to find the right experts, to find the right ground truth for the data, because at that point when you're not in long context, it becomes about, okay, can it find relevant evidence across hundreds of thousands of pages, tickets, files, prior turns, right? Does it maintain the state over and follow constraint over long trajectories without drifting or contradicting itself, right? If you use any frontier model today, you're going to notice that after 10 turns, it's not as sharp as the first one, right? And I think that really evaluating that for a model like this it becomes pretty much critical. Does it perform old as the context length grows and all of that? So these really requires not only environments that are that have that long context by definition, right? Thousands of documents and environments that are really realistic in terms of content that can be actually extracted from documents and files of all kinds, but also then it requires ground truth that is and also multi-hop type of reasoning ground truth that is not easy to find in the wild. That means expert humans, but also really good realistic source data, right? Because yes, you can create a realistic PDF that is 2 pages, but when you're now starting to really reason across hundreds of documents, for example, financially, that becomes on the financial space, that becomes extremely complicated. So it all relies on human expertise and also the right pipeline and the right evaluation setup in order to make this run.
We're talking a lot about long context. And Alex, do you think it's a feature or a foundation? Are we at the point where you build differently because of it, or is it still mostly for future potential?
Oh, I mean, definitely building differently today. We have done a lot of exploration internally and now are doing exploration with our design partners on how you would build differently with long context. And I talked a bit about this earlier. What we're seeing is a lot of simplification to lead to better generalization. This is a concept that has been termed the bitter lesson. It's been around, like that as a concept, it's been around since far prior to that essay in 2019. But basically, the idea is that you can build systems through human curation. You can build machine intelligence through human curation or through generalizable, scalable methods that learn in a more black box way. And the bitter lesson is that humans are biased towards taking the former approach, accessible, interpretable, etc. But the latter approach always wins. We've seen this endless times recently. If you compare Google Search and Google Translate to ChatGPT, for example, you can see how black box, super scalable systems often, can lead to new capabilities and scale in a way that the human curation of the system build out can't. And if we look at the space today, on top of the $20 billion or so of LM API spend, most of the expenditure is into human curation, whether it's prompt engineering, retrieval mechanism curation, conditional logic curation between steps and workflow, all these different things. And but the reality is, each time you add one of those components, you actually limit the generalization potential of the system. So when you add conditional logic, you make the scope that system can tackle more narrow, or narrower, I guess. And we are enabling people to build, and you're making trade-offs. Like each time you chunk a document, each time you create an intermediary abstraction, there's lossiness. You reduce the amount of contiguous context. So the reality is that people are making all these trade-offs today due to limitations of cost, latency, or intelligence, or absolute size when it comes to context. If you remove those limitations, then you can now build systems without making those trade-offs. And so in super tangible ways, that means when you're processing financial documents that are hundreds of pages long, instead of needing to chunk those documents, create abstractions around each of the chunks, and then pass those abstractions into a final analysis to get insights, you can simply dump the 10Ks from the last 5 quarters into the context window and analyze those as whole artifacts, enabling you to tackle much more challenging problems on those documents with much more challenging reasoning without the trade-offs. For knowledge bases or RAG products, people can use more chunks, multiple coarser grain retrievals in a single step, potentially not chunk the documents that are being used as input at all, retrieve a higher top K, so on and so forth to lead to a better outcome without worrying about context rot, an increase in cost, or an increase in latency. So those are some of the ways that we're seeing people build differently today, in addition to what I talked about earlier with agentic workflow compression and longer horizon memory. So,
Sergio, where do you see long context moving the needle for end users?
Yeah, that's a really good question. I think personally and maybe selfishly, definitely where we've seen long context really making a difference right now, it's probably the most obvious one, which is coding. I think vibe coding is not going to be right now. I feel at some point we're gonna all of these applications that we're vibe coding are gonna potentially not be maintainable anymore, or to the same degree of success, right? And I mentioned coding because of course everyone now is a vibe coder and everyone now builds software to some degree, whether it's your little app that you vibe coded and you publish it in the app store, or your little wannabe enterprise tool. I think one of the problems that we're seeing more and more with vibe coding is, okay, once your code repository gets insanely complex, that's where the model starts becoming inefficient and highly inefficient. And that's the point where, oh, okay, I have to start thinking about how to potentially chunk my request into the model or increase the focus into particular files or ways into solving the problem. And I think it becomes extremely hit and miss. And I think that that's the first thing in which we've seen a lot of value in long context is being large repositories with like large amounts of code and large amount of files. I think another one in which we've seen, of course, and I think there is a lot of value is just databases, right? I think Appen has done a lot on the natural language to SQL side, and I think that especially when working with large tables that might have very complex joins across tables or across schemas, that's where it becomes extremely tricky to interact with the database or getting the right results. You might getting results that look right but aren't necessarily right because of the lack of context. And I think honestly, and Alex, I'd like to hear your thoughts as well. Is one of the things that we've seen with a lot of customers, especially in the enterprise space, as they tried RAG, was natural language to SQL was their way of leveraging legacy systems and also go around some of the limits of RAG because of context. But now we are reaching the point where, okay, natural language to SQL works in certain scenarios better than RAG, but it's just then when you're working on multi-query, multi-context, multi-schemas, that's where it lost. So I think its main purpose is still probably, and its main benefit for enterprises is going to be data retrieval, and for engineers, probably mostly going to be on coding. But Alex, curious to hear your thoughts there as well.
No, that makes sense. I mean, my main frustration with coding agents is the long horizon memory. I get quite frustrated with it. And I think if we extend that a little bit further too, this is a big challenge within coding agents, where you have these engineers expending great amounts of effort, managing, skills, Cloud.mds, etc. So like manually curating the context. Even then, long horizon memory is falling quite short. And you can imagine when we move beyond coding agents and more into like general workforce productivity agents, just how hard it is going to be to manage long horizon context, where I think people are much less likely to go through all this effort of manual creation of files. Like that's software engineers used to working that way. Other people in the workforce, I think, much less so. So, in fact, I've worked with a lot of non-technical people, helping them learn how to use Cloud Code, and it is that's the part where they struggle the most. They're like, I have to maintain all this stuff manually. That's crazy. I thought this was going to make my life easier. So, so the fact that it's already a problem for us as coders, I think means it's going to be an even more immense problem as we move beyond coders into general workforce productivity for long horizon autonomous agents. So yeah, totally good on that one. And then on it's interesting you bring up the database side. So there are many things that led us to where we are today, but one of them is a use case, a Texas SQL use case that I did when consulting with a finance company in 2023. They had over 700 tables with an average of 10,000 columns each, and schema management was like an absolute impossibility within the context window, let alone like sample files, any verification, etc. Or sorry, sample rows, verification, etc. So I think Texas SQL is still fairly unsolved. I think there are too few products still that are really good at it, and a lot of it does come down to context. Even if it's sometimes it's again it's usually not just like one axis of context. There are 4 different axes. You have the absolute size, the cost, the speed, and then the intelligence level. You can have great speed, latency, and 1 million token context window, and a C context window quality degradation beyond 100,000 tokens. And so that 4th axis of quality within the context window also matters. Anyway, you have those 4 different axes, and I think, to be honest, for Texas SQL, all 4 of them play a role at some point typically. So that I'd love to see Texas SQL take off a little bit more than it has. Tabular data is like, enterprises have more data in tables, whether it's spreadsheets or databases, than they do in text. And that market is still, I think, very immature. So.
And I think, if we look at legacy, right, databases, probably 99% of the data in the world is tabular on some form, right? Could still be an Excel spreadsheet or an Access file, whatever, if someone is using Access databases. But I do agree with you. I think we haven't put the right focus as an industry in really going where the enterprises are in terms of databases. We just assume that that's why I wasn't ever a strong believer on RAG in the first early days, because it's like, oh, how many companies actually have documents that are structured in a certain way and are just going to be ingested right away? Tabular to me looked like the obvious choice to begin with. Not sure why we haven't put the right care there.
Well, exactly. You just actually said something that we're seeing a lot with enterprises, is that the data isn't structured in a certain way. So like, one of the benefits that we're providing to folks is that they can start getting value from enterprises, is they can start getting value from the data a lot earlier in the process of AI transformation. So we've talked to SIs where they say that they have to do a $10 million data transformation project before they can even start on actually building an AI product on top of that. And what we're saying is like that structuring is going to be a lot easier because you're going to be able to lean a lot more heavily on the model. You're going to have to do a lot less chunking. You're going to have to do a lot less experimentation around what works for retrieval. And that's something that's really exciting to enterprises, because I agree, like if you have to reduce everything to small chunks and create solid retrieval mechanisms around that and good prompts to manage the lack of contiguous context, it is really hard to deliver on high expectations for product quality. If you can lean a lot less heavily on the data needing to be structured, you can see much better results. So
I want to move a little bit to the benchmark because looking at the numbers, it's your model, Alex, is 56 times faster, 100% retrieval at 12 million tokens. I need to know what's the difference between what the benchmark proves and what they don't. What should readers take away from these reports?
sure. And by the way, you all got it pinned us at 98%, not 100% at 12 million tokens. But yeah, so the which was actually slightly inconsistent with our previous benchmarking, but we're happy to take the 2% loss. So the in terms of what it shows and what it doesn't. So to be honest, long context benchmarks are pretty bad right now. In fact, I would like to see a couple more, and we're actively working on creating some. As you all know, we're working on talking to you all about working on some together, some where we have no access to the data, and it's well protected for the entire industry. But long context benchmarks right now are mostly they're mostly retrieval focused, and there is one that we really like that does focus on. There's a ruler suite of benchmarks that we like quite a bit because it's 13 different tasks. 8 of them are different variations of needle in a haystack tasks. One of them is a variable tracking, kind of like a counting oriented task. You have frequent common word extraction, which are counting oriented. You have question answering tasks, including one that is multi-hop reasoning Q&A, which means in order to answer the questions, you have to find multiple pieces of information around within the context and reason around those multiple pieces of information to answer the question. So I think that's probably the most robust benchmark in the industry today in terms of evaluating holistically long context performance. I'd say the second one is maybe the long context reasoning benchmark from artificial analysis. That's one we find super interesting. The challenge with these is that for Ruler, the original evaluation went up to 120,000 tokens, and beyond that, there are some limitations due to synthetic data generation pollution. It's easy to have like overly redundant abstractions and such. And then for the long context reasoning benchmark, the average input size is around 100, somewhere between 100 and 120,000 tokens. So we really don't have robust million token plus long context reasoning benchmarks. And so the benchmarking that we did together was focused around the single needle UUID task from the Ruler benchmark and extending that up to 12 million tokens. And that's great for assessing retrieval, and that's super important. And nobody's ever shown retrieval performance up to that size before, which is exciting. What is yet to be fully evaluated is reasoning capability. And frankly, there is no benchmark to do that. And so it is upon us now to create a benchmark that assesses 1 million token plus reasoning capabilities. And I mean, that's just total greenfield work that we're going to have to do together. So that's where I think things are still early, is fully understanding how to benchmark that and what that looks like today. And then additionally, understanding what user preferences are at those sizes. So one of the main reasons we're doing design partnerships right now is that mapping user preferences for long context tasks is total white space. In the same way that when you create a model in research, or I guess when you create a model, like that model goes through tons of iterations for red teaming, user testing, etc., to make sure that what users actually want in the model is there, and that's independent of like the technical capability of the model architecture or the team behind it, there's simply a process required to figure out what users are actually looking for in the model as a product, as opposed to simply a research output. And there's not that much to lean on for what people want to, how people exactly want to use or expect a response to be formulated, or expect reasoning to be done, or summarization to be done at the multi-million token scale. And so that's what we're exploring with design partners, to take our product from, a highly technically capable research product to an actual product that is delivering on expectations in the market. So that's, I think, kind of the gap between what we've evaluated and validated so far to release to the market, and what's on our immediate roadmap. So,
Sergio, you and I have been talking a lot about benchmark credibility, self-reported numbers, selective test selection, in the market really not knowing who to trust. So I want to know, what does your team do specifically to make sure you're not validating what your client wants you to find?
That's a really good question. I think that with the way we run our evaluation is truly independent, right? So we look at of course, we get access to the model. We decide with our customers, okay, which ones are the benchmarks that make sense to test it on, and those are all public, right? And so that really allows us to make sure that we're downloading it from the official sources. There isn't anything in between in which the customer, let's say, has a say or an ability to edit or really break the chain of trust. Let's call it that way. Additionally, there is never a single individual that runs everything end to end, but we have a research team, and the reason why we have multiple individuals, and those multiple individuals are also named in our reports, is to actually make sure to give an accurate view of the results, right? Results can oftentimes be interpreted, right? And we think that having that dual approach in which, okay, are you reading what I'm reading? And it's two separate individuals that have run different aspects, not necessarily of the same benchmark, but the overall evaluation of a model really makes sure that we are able to really make an independent assessment as much as possible. And at the end of the day, what really happens is the customers is shown those results, and from that moment on, if there is our logo, it means it's been fully independent. The customer can only sign off. Okay, it makes sense. The customer, of course, has the same the way the evaluation has been run to make sure there haven't been mistakes on how, because especially as it's a new API, it's a new model, it has new parameters. We want to make sure that those initial settings are correct for what we're trying to evaluate. But the customer has absolutely no say in the ingestion of the data, how is it ingested, and also once the results come up, the only choice that they have is just confirm, if they're disappointed or not, but that very truthful to the evaluation that we run.
This is my last question, Alex. We're going to go back to the future. What's next on the roadmap?
Yeah, next on the roadmap is enterprise commercialization. So we have some really exciting design partners that we're working with right now. All of them are spending 8 to 9 figures on tokens, and have use cases that would be dramatically transformed by long context. And so working with these folks to make sure that we're building a model that can deliver on the value premise in these large scale, highly complex systems is number one. And the differentiation primarily is long context reasoning capability as the wedge. Additionally, we're looking at long horizon agentic capabilities, and considering specializing in a couple verticals as well. Not in that we would have a finance model and a coding model, et cetera, but rather figuring out where we need to spend more time than we typically do on any particular vertical due to demand from clients and commercialization value. We are creating partnerships to help with distribution when it comes to solution integrators or clouds. And we are also thinking about the future. So SSA is the first many that we plan to release. SSA primarily addresses compute efficiency, but we also care about sample memory efficiency. We do have a follow-up to SSA that we've been working on for the last few months, and continuing to bring that to production in full scale is going to be really important.
Alex, Sergio, thank you so much for today's chat. It was so great to look at the futuristic view and see the results of the benchmark and where we're going as an industry. To our listeners, I want to thank you for tuning in, and we'll see you next time.
Awesome. Thank you so much.